Hi, welcome to tight bound running time calculation for given function linear function 4n plus 5 equal to big theta of n. We can ask this question as show that 4n plus 5 equal to big theta of n. From this find C1, C2 and initial input size N0. For computing the tight bound calculation, we are having the criteria 0 less than or equal to C1 into G of n, less than or equal to F of n, less than or equal to C into G of n. For all input size greater than initial input size N0. Here N0 is positive number, so it will be greater than 0. C1, C2 also positive numbers, it should not be a 0, right? So now based upon the given condition, the given function is 4n plus 5 f of n. We are substituting the f of n in the place of f of n. Then here we will take the equivalent term in the left side. So in the left side here given function 4n plus 5 dominating term is nth term when comparing to the constant 5. So we will take the dominating term 4n, dominating term with coefficient 4n. So equivalent or smaller number, equivalent number is the 4n, smaller value is 3n, 2n, then 1n. Like that in the RHS, here in the RHS we will take the dominating term 4n and the coefficient 5 and the dominating term n. So here why we are taking this two terms in the sense we can the greater values after the 4n is greater value or equivalent value. So for that we can take equivalent value 4n, then 5n, 6n, 7n, 8n, it's etc infinity number of terms. So here 9n also coming in this range. So what we are taking here this coefficient 5, that constant value 5 and the dominating term n. So we are taking that, right, because it is greater value than the f of n. So when you are taking this will be 9n. So 4n less than or equal to f of n 4n plus 5 less than or equal to c2 into g of n. So here c1 is 4 and c2 is 9. Then we will substitute the value n0 equal to 1 because the n0 will be always positive number, so we will substitute the 1. When you are substituting the n equal to 1, here it will be 4, then here it will be 9 less than or equal to 9, so which is true for n equal to 1. Like that when you are substituting the n equal to 2, when you are substituting n equal to 2, then 4 into 2 8 less than or equal to here 8 plus 5 13 less than or equal to 9 into 2 18. So this is also true. So from this we can define for n greater than or equal to 1, all n greater than or equal to 1, this function will satisfy the given criteria. So we can say c1 into g of n is less than or equal to f of n less than or equal to c2 into g of n for all n greater than 1. Here we have taken n0 is 1. So we can define finally f of n equal to big theta of g of n equal to big theta of n for given, I mean identified constant 4. Here this is the c1 is the 4 and c2 is the 9 and initial input size is 1. Like this we can have different infinity number of inequalities. For example, when you are substituting the 3n in this place, in this c1 into g of n is 3n, and here we may substitute 6n here. we may substitute 6n into C2 into g of n. So we will get different C2 and C1 and n0. So different kind of values we will get based upon the given inequality function for tighter bound. Thanks for watching.